Hello and welcome, and in this video we're going to be introducing polynomials. And I know you might be asking yourself, well, what is a polynomial? Well, this is a polynomial, this is also a polynomial, so is this, and guess what? So is that. Now, what is not a polynomial is something like these. These are not polynomials. And I know you might be asking yourself, well, you really still haven't told us what a polynomial is, so what is it? Well, all a polynomial is any algebraic expression that all of its constants and all of its coefficients are real numbers, okay? So we're not gonna have any imaginary numbers in a polynomial expression. And all the variables have non-negative exponents. So they're all whole numbers. Okay, so as we can see here, we have exponents of 2 and 5, and you can kind of think about this as x to the 0 right here, -1 times x to the 0. Here we have an exponent of 1 on x, we have exponent 4 and 3 and 1, and then here is just a number. So just a number like 10 is also a polynomial, technically. However, here we have a fractional exponent, so that actually introduces us into what a whole number is. And we talked about this a little bit. Whole numbers are things like 0, 1, 2, 3, 4, so on and so on and so on. So we cannot have any fractional exponents, because if we have a fractional exponent, what you're actually seeing is a radical, and that is a radical, not a polynomial. We also cannot have negative exponents, because a negative exponent actually means that we have a variable in our denominator. And this is what we call a rational expression, so it's not polynomial. So the takeaway here is real numbers. We need real numbers across the board, okay? And our variables have to have whole number exponents. They cannot be fractions. They cannot be negative. I can't see any variables underneath a radical. I can't see any variables in a denominator. So that is what a polynomial is. Now, since we now know what a polynomial is, it's probably a good idea to talk about some of its key characteristics and how we can classify polynomials, which we've actually already been doing a little bit, because linears are polynomials and quadratics, what we just covered, are also polynomials. So we actually already talked a little bit about this. Now here we have a polynomial. Okay, we have a polynomial of 3x to the 4th minus 5x squared plus 1. Now, one thing that you might notice is that all the exponents are going down in descending order. We have our highest exponent first on x, and then we go down, down, down until we just have a number, a constant, okay? And that's actually what we call standard form of a polynomial, where we have the highest exponents first and then the lowest exponents last. So this is in what we call standard form. You can also hear that referred to as descending order. Now, degree is simply, the degree of a polynomial is simply the highest exponent on your variable if there is only one variable. So in this particular case, we only have one variable. That variable is x, and the highest exponent is 4, so the degree of the polynomial will be 4. Okay. Now you could technically have a polynomial that, say, was like 3x to the 4th y squared plus 2xy cubed minus 2. Okay, and if you have a polynomial that has multiple variables, the way to find a degree is you're going to need to add the exponents on each term. So here I would add the exponents on x and y, so the degree of that term would be 6, and the degree of this term would be 4, because I have x to the 1st and y cubed. Okay, now we're going to be focusing mainly on single variable polynomials, because then we want to solve them and graph them and stuff like that. But just know you could also expect to see polynomials in multiple variables. And the way you find a degree there is you add up all the exponents on your variables in each term and determine which one is the highest. But back here, our degree of this polynomial will be 4. Now we need to know how many terms there are, and we just talked about quadratics and quadratic trinomials, and what we're seeing here once again is a trinomial, because there's 3 terms. 3x to the 4th is one term, negative 5x squared is another term, and positive 1 is the third term. So this actually has 3 terms, okay? And the leading coefficient is the coefficient on the term with the highest degree. But what's nice is if we have it in standard form like this, highest exponent, the lowest exponent, is going to be the first coefficient. So the coefficient on this one is actually 3, because we have 3x to the 4th. Now the leading term is 3x to the 4th, but the leading coefficient is just 3. And the constant is the number that doesn't have a variable. It's constant. This term here is going to change based off of the value of x. Same here. Well, this one, that doesn't have an x, that's always going to be 1. That's constantly going to be 1. So the constant is the term without a variable, which is going to be 1. Now, if you don't have a term that doesn't have a variable, that means your constant's 0. Because if I had like a plus 0 at the end of something, that actually doesn't change anything. So this would be all the key information for this particular polynomial expression. And the reason that all of these are important is because once we get to graphing polynomials, the degree of the polynomial is going to tell us what's called the end behavior of the graph itself, and also how many zeros that graph is going to have. Stuff we'll be talking about a little bit later. Any constant is also going to represent a particular intercept, and we talked about this a little bit before. Now let's take a look at another polynomial expression. So let's take a look at this one. So as we can see here, once again, it is in standard form, highest exponent to lowest exponent, and that highest exponent on x is 3. So we have a degree of 3 because we have x cubed, and that is the highest exponent on x. Now there are only 2 terms in this particular polynomial. We have 6x cubed as one term and negative 5 as the other term. Okay, now the leading coefficient right is going to be 6, because that is the coefficient on the term with the highest degree, the highest exponent, and our constant is going to be the term without a variable, which is negative 5. Now, that's all fine and dandy and everything, but I also want to talk about classifying polynomials. And we've been talking about this actually a little bit. In the last unit, we talked about quadratic binomials and quadratic trinomials, and that is actually some of the classifications that we can have. We can classify based off the degree of the polynomial. So if the degree of a polynomial is 0, something like just the number 10, we said that was a polynomial, that has a degree of 0 because there is no exponent. That is what we call a constant. We already talked about linear functions. Linear is a term, is a type of polynomial. We already talked about quadratics. Quadratics are a type of polynomial. Well, we are going to be talking about some higher degree polynomials now. We have cubics, we have quartics, we have quintics, and it does go on and on and on, but we're going to kind of cap off right around a degree of 5. We can also classify based off the number of terms, and we already talked about this a little bit. We talked about binomials and trinomials when it's 2 terms and 3 terms. Well, if it's only 1 term, that's what we call a monomial. And if it's 4 or more terms, we just call that a polynomial. We don't necessarily have a nice name for that. So now that we talked about the degree of polynomials and how many terms a polynomial has, we can start classifying by both of those. So if I was taking a look at this example right here, we said that the degree is 4 and the number of terms is 3. So I can classify this as a quartic trinomial. And if I look at this polynomial here, we said that this is a degree of 3 and it has 2 terms, so that would be a cubic binomial. And that is classifying polynomials. This is vocabulary that you are going to need to know because we do cover this quite a bit. You're going to be hearing me talk about, okay, here we have a quintic polynomial of 6 terms. Here we have a quadratic binomial, which means it's 2 terms. We're going to be talking about that. And we're also going to be talking about special factoring methods based off the degree and also based off the number of terms. So make sure that we know how to classify based off the degree and the number of terms, which means we have to know how to find a degree and the number of terms. I hope this video was helpful. If there's any questions, please feel free to let me know, and I look forward to seeing you guys in the next video.